The objective of this course is that we want to introduce to you the architecture and organization of a computer with emphasis on instruction sets, hardware and microprogram control, processor design, pipeline processing, vector processing, memory hierarchy, and DMA controller. And whenever the total course will be taught, so that by the end of the course, you will be able to understand the basic architecture and organization of a computer. Now, first we discuss some history of developing the computer system. Now, the history of attempt to make machine that could perform long sequence of calculation is fairly long. The abacus was the first man-made computer. You know from your childhood there is a device known as abacus, and you can call abacus as the first man-made computer. And the abacus used some beads tied in with a string in a frame to represent and manipulate numbers. Now, in the 17th century, Pascal first built a simple digital calculating machine. Now, in 1822, then Babbage proposed a machine known as difference engine. After some years, in 1834, he conceived another machine known as analytical engine. Then another scientist known as A.M. Turing proposed theoretically an automatic machine. The machine proposed by Turing, the basic theory proposed by Turing, is nowadays also used in the design of computers. Now, the first automatic computer which was designed, developed, and used to work was an electromechanical computer or electromechanical machine. Electromechanical means it will have some mechanical components, relays, and so its speed of operation was not high. Next, the first all-electronic machine which was developed is known as ENIAC. You already know the name. ENIAC stands for Electronic Numerical Integrator and Automatic Calculator. It was completed and put into operation in 1946. It was designed in USA, and the size of the machine was like a hall. It was put into a hall. You have come to the department in the first floor, the class, Jane Var Auditorium. The size of the machine was like that. It was huge in size. Now, as in different regions of the world, different scientists or engineers were trying independently to manufacture or design a machine which will be able to manipulate or perform mathematical calculations. They were doing independent works. So it was suggested that a general rule will be formed so that all the work done by individual ones can be combined. And the machines which were designed based on these laws is known as von Neumann machines or IAS type of computers. So what are the rules of design specification of the von Neumann or IAS computer? There were 4 broad design specification of IAS or von Neumann type of computer. The aim was to build a machine which will be general in purpose. The machine should be general, that it will be able to perform any type of mathematical calculations. Second specification was it should be fully automatic. It should be automatic in operation. Third point was it should be electronic.
Ma'am,
follow.
I am 302.
Huh?
My mic is not working actually. That's why.
What I will do? Hello? Can you all the students hear me?
Yes, ma'am. Yes, ma'am.
So there were four broad design specifications on which, based on which all the von Neumann or IS type of computers were designed. First specification was should be general in purpose. That means the machine will be able to perform any type of mathematical calculations. Second specification was it should be automatic in operation. Third one, it should be fully electronic. No mechanical parts will be there so that its speed of operation will be high. Fourth one is all the arithmetic operations should be digital. First, it was specified that it should be digital. Now you know that all the switches has only two steps, that is off and on. So it was more specified as all the arithmetic operations should be binary. Not only digital, it should be binary. So how we will design the machine following this specification? As the machine should be able to perform arithmetic operations, so it must have an arithmetic unit. The machine should have an arithmetic unit which will be able to perform arithmetic operations in digital, especially binary. Now, as it should be fully automatic, it must have some storage unit or memory, which is also known as memory, so that first the user will store the requirement of the problem into the machine, and the machine will automatically perform step-by-step calculations and finally give the result to the user. Now, not only arithmetic and storage unit, it must have some input and output unit through which the machine will communicate with the external world or the user. Through the input and output unit, the user and the machine can communicate with each other. Generally, with the help of the input unit, the user can input information into the machine, and through the output unit, the machine can pass on the result to the user. So it must have some input and output units. Input and output units are sometimes abbreviated as IO unit. Fourth one, it should be a general purpose. So the machine which we will design must be able to perform any type of calculations. Now for a particular type of calculation, several steps will be followed. Say you have an example, you have a problem where first you will have to multiply, then add, then subtract, then divide. In another problem, you will have to first divide, then add, then multiply. So different steps will be followed to perform different calculations. Now, as the machine is a general type of machine, so it will be able to perform all the operations. So the machine must have a control unit which will instruct the machine to follow the different steps required to execute the problem. So it must have a control unit. So the machine must have an arithmetic unit to perform arithmetic operations, which will be binary in. Second is, as it is fully automatic, it must have a storage unit, generally termed as memory. As it is a general purpose machine, it must have some control unit which will instruct the machine to follow the different steps to execute different operations. And it must have a IO unit to communicate with the external environment. Clear?
Yes, ma'am.
So these were the basic broad requirement, and according to the requirement, the basic units of the machines are these. First, we discuss what will be the basic operation or the structure of the arithmetic unit. Now, I have mentioned that what will be the purpose of using the arithmetic unit? The arithmetic unit must be able to perform arithmetic operations. Now, what are the basic arithmetic operations? Basic arithmetic operations are addition, subtractions. So the machine must be able to perform these two operations. You can say that multiplication, divisions are arithmetic operations, but I can say that multiplication is nothing but a repetitive process of addition. Similarly, division is nothing but a repetitive process of subtraction. So if my machine can perform addition and subtraction, so it can be able to perform also multiplication and division. So in the earlier days, the machines which were designed, the arithmetic unit was able to perform only addition and subtraction, not multiplication and division. But nowadays, all the machine can perform all these operations. Now, again, it can be shown that, we will later discuss that, subtraction is nothing but complementing and then adding. So only the basic arithmetic operation is the addition. So if my machine arithmetic unit is able to perform addition, it will be also able to perform subtraction, because subtraction is nothing but complementation then addition. Now this addition can be performed in two ways, either serially or parallelly. If you have the circuit which performs addition is known as adder circuit. So you can have either a serial adder or a parallel adder. Now here I stop and ask you that you have already learned in your previous classes full adder and half adders. Yes?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So with the help of a half adder, what does a half adder does? A half adder adds two binary bits only. Whereas what is the purpose of using a full adder? Full adder can add 2 bits as well as carry from the previous stage. And the output of the full adder circuit is a sum output and carry to the next stage. Now these adder circuits can be of two types. One is serial adder and the other one is parallel adder. Now each have their advantages as well as disadvantages. Now as for example, if we have a serial adder, then if we want to add two n-bit numbers, then first the LSB bit of the number, two numbers will be added, then the next higher order, then the next one. So it is a slower process. But the total hardware requirement is only a single adder circuit. Whereas in a parallel adder, what is done? If we have a n-bit number, two n-bit numbers which will be added, we require in hardware circuits, in adder circuit, so that all the bits are added simultaneously, and it is much faster. So parallel adder is much faster than serial adder, whereas the hardware requirement of a parallel adder circuit is large in comparison to the serial adder. Now, as in an adder circuit, we require two data. In many of the organizations, what is done? Within an arithmetic unit, a main subunit is used, which is nothing but a storage register known as accumulator. So one of the data which will be added is available with the accumulator. So when addition is done, the addition is done with the content of the accumulator, and the other data comes from any other places. So in some organization where a special register known as accumulator is used, there always one of the data will be available in the accumulator. And if another data is required, that comes from other places. So that is another type of organization of an arithmetic unit, where we use a special register which is known as accumulator. So this is known as accumulator type of organization. Next, we move on to storage unit or the memory unit. Now, what will be the purpose of using the storage unit or the memory unit? It must be capable of storing two different type of operation. One is the numbers or the data. Also, it must be able to store the instructions. Now, instructions, how? Because I have already mentioned that as our machine is fully automatic, initially the user will introduce or store the steps required to be executed by the machine in the memory, and after the data is stored in the memory, it is executed taking it from the memory by the machine. Now, so what are the different type of data that will be used? Not only numbers, also it will some instructions. You want to add, you want to subtract, you want to move, you want to delete. So that those are known as instructions. Now, basically, the storing places can store only the digits, and as it is a binary instrument, so it can only store either zeros and ones. So the instructions which will be stored in the memory unit, they will be stored in the form of a code. Now, depending on the bits available in the storing unit, the different type of codes can be stored in the memory. If it has n number of bits available, then 2 to the power n number of different code can be stored in the memory unit. Clear holo? So the memory will not only be able to store the numbers, but it will also be able to store the instructions. But the instructions will be stored in the memory in the form of a code, which is nothing but a collections of zeros and ones. Now, what will be the use of the memory? The store on the memory unit must be capable of storing information, not only storing information, but making it available during the course of computation and erasing the existing one to make space for the new data. Now, the total number of memory unit or the storing unit available is fixed. So, if you have no way of erasing some of the older data, it will not be able to store new data. So the purpose, the duty of the memory is not only it should be able to store information, it should be able to supply the data during the course of computation as required by the machine, and also it will be able to erase the existing data to make space for the new data. Now, how the memory is organized? So memory has different locations. Say it has 100,000 locations. Now, this how the certain locations are organized. The memory is organized into a large number of locations, each of which can hold a number. Now, this say we have 1,000 locations. Now, how we will identify each location? First location, second location, third locations, how you will identify the different locations. So each location must have a address. So each location is identified by an address. As for example, say in your locality, there are a number of buildings. Each building has an address, and from the address, the particular building is specified. Similarly, out of the available number, total large number of locations, each location must have a fixed address, and from that address, that particular location in the memory can be identified. Now, the information which can be stored or retrieved from the memory again can be done either serially or parallelly. The information which will be stored or taken out from the memory can be stored or retrieved either serially or parallelly. Clear? Understood? Basic idea understood?
Yes.
We
Yes,
will
ma'am.
discuss later
Yes,
on
ma'am.
in detail. I am just discussing. Next one is input-output unit. These units connected to the computer help the operator to insert information to the machine and to give result to the user. But they are known as peripheral because they are not directly connected to the machine. They are not controlled by the machine, directly controlled by the machine. They are connected to the machine externally. So they are known as peripheral devices. We will discuss it later on. Last but not least is the control unit. What is the operation of a computer? The operation of a computer consists in obtaining information from one or more sources, routing these information through specific path, making the processed information available at the output. All these activities are governed by the control unit. So control unit basically controls the mode of operation or the execution of the machine. Now, first, I have mentioned that whenever the von Neumann machines were designed, they were all electronic, not electromechanical. And the electronic device which were used was in the form of vacuum tubes. তোমরা হয়তো পড়েছো কিনা জানি না, তোমরা কি vacuum tubes পড়েছো কিনা জানি না, gas discharge tubes. So they were slow. Those slow, inefficient subsequent advances in the computer system, the slow, inefficient vacuum tubes got replaced by the transistors and then monolithic ICs. These have then undergone revolutionary changes. ICs, first small scale to medium scale, then medium to large, and last, very large scale integration or VLSI. Now it uses VLSI circuits. And as the circuits are miniaturized, it reduces the stray capacitance because connecting wire size of the connecting wire decreases, and hence the stray capacitance decreases, and hence we can achieve higher speed. Now, only the problem of von Neumann type of machine was that the feature of interrupt facility were not visualized by the von Neumann computers. Von Neumann computers do not consider the feature of interrupting the machine either externally or internally. However, today no machine is designed without a variety of interrupt facilities. Nowadays, the machines which are designed has an interrupt facility. But von Neumann machine had not the idea of this interrupt facilities. Okay, so this is the basis of the development of the design of computers. Now, what we mean by the term organization and what we mean by the term architecture. Organization is concerned with the way the hardware components operate and the way they are connected together to form the computer system. The various components are assumed to be in place, and the task is to investigate the organizational structure to verify that the parts operate as intended. So that is the beauty of organization. So by the term organization, we understand that the hardware components are already there. The designer has designed the machine. The organization specifies the hardware components as well as how they operate. The various components are assumed to be placed, and the task of organization is to investigate the structure and to verify that the parts operate as was intended by the designer. That is the purpose of computer organization. Now, whereas what is architecture? Our computer architecture is concerned with the structure and behavior of the computer as seen by the user. User মেশিনটাকে কিভাবে দেখছে? ইউজার দেখবে না যে তার কি কি হার্ডওয়্যার আছে, সেটা কনসিডার করবে অর্গানাইজেশন। ইউজার যখনই ডিজাইনার একটা মেশিন ডিজাইন করবে, সে ডিজাইন স্পেসিফিকেশন বলে দেবে যে এই মেশিনে আমি এই হার্ডওয়্যার দিয়েছি, তার জন্য এই কাজ করতে পারে। সুতরাং সেই স্পেসিফিকেশনগুলো দেখে user, so architecture is concerned with the structure and behavior of the computer as seen by the user. User মেশিনটাকে কিভাবে দেখছে, that will be specified by this architecture. So basically architecture includes the information formats, instruction sets. তার মানে তোমার মেশিন কি কি ইনস্ট্রাকশন এক্সিকিউট করতে পারে, সেই ইনস্ট্রাকশনস গুলো কিভাবে লেখা হবে, কোন ফরম্যাটে, হোয়াট উইল বি দ্য ফরম্যাট, and the techniques for addressing the memory. In the memory, thousands of number of locations, such as how you will address or specify a particular locations. That is governed by the computer architecture. So first, designer designs the machine. So the designer arithmetic ইউনিটটাকে ডিজাইন করবে, ডিজাইনার আইও ইউনিটটাকে ডিজাইন করবে, ডিজাইনার মেমোরিটাকে ডিজাইন করবে, কন্ট্রোল সার্কিট ডিজাইন করে তোমার মেশিনটাকে ডিজাইন করে দিয়ে দিল। তার সঙ্গে একটা ম্যানুয়াল দেওয়া থাকে, তাতে বলা থাকে এই হার্ডওয়্যার আছে, সুতরাং এইগুলো কাজ করতে পারবে এইরকম ফরম্যাট। এবার অর্গানাইজেশন দেখবে কি কি তার হার্ডওয়্যার আছে এবং সেগুলো ঠিক ঠিক আছে কিনা এবং সেইগুলো ঠিক মতো কাজ করছে না। আর আর্কিটেকচার কি দেখবে? আর্কিটেকচার হার্ডওয়্যার কিছু দেখবে না, আর্কিটেকচার স্পেসিফাই করবে ইউজারকে যে সে একটা প্রবলেম সলভ করতে গেলে উইথ দ্য মেশিন কিভাবে ইনস্ট্রাকশনস গুলো লিখবে, কি কি ইনস্ট্রাকশন এই মেশিনটা কাজ করতে পারে, and what will be the format of each instructions and how the memory will be addressed. So these are specified by this architecture. So you understand the difference between organization and architecture. So we will discuss both the organization and architecture of a computer. Okay. Now we will discuss different number systems. Now you already know this, just I will go through just a revision type. There are different number systems, how we define a number system. A number system of base or reduced R is a system that uses distinct symbols for R digits. Decimal system has, what is the value of decimal system R? Decimal system has R as 10. So what are the different symbols used? 10 different symbols are used in decimal system. 0, 1, 2, 3 up to 9. Whereas binary system has R as 2. So it has two different digits, 0 and 1, to represent any number. In addition to decimal and binary, there are other number systems which are important to computer application. One is known as octal and the other one is known as hexadecimal. Octal has R as কত? বলতে পারবে octal এ R কত আর hexadecimal এ R কত?
8 and 16.
8 and 16. Out of 8, 0 to 7, 0, 1 to up to 7 are the different digits. At 16 হচ্ছে কি 0 to 15, sorry, 0 to 9, then
A to F. A to F.
A to F. Very good. So these are the examples. Now you must be aware of how to convert any number from any base system to another system. So in your internal assessment examination, first internal assessment examination, there will be some questions where you require to transfer any number from one system to another system. Decimal to octal, decimal to hexadecimal, or octal to hexadecimal, or octal to decimal, binary, and so on. So you must be aware of all the conversion of the number system from one system to another system. Not only real, integers, but also fractions. Real numbers, you must be conversant how to transfer one number from one system to another number system. Next one is complement. Now I have already mentioned you that in our system I will show you that you do not require any subtractor circuit to perform subtraction. Only by complementing the subtrahend and then adding it with the minimum, you can perform the subtraction. So subtraction is basically equivalent as complementing, then adding. So what we mean by the term complement? Complements are used in digital computers for simplifying the subtraction operation. Now there are two types of complement used for each base. So for an R number of system, there are two complement. One is known as R's complement and the other one is known as R minus 1's complement. So in binary system, what are the two complements? What will be the two complements? The
Zero's complement and one's complement. Sorry, ones and two's complement.
Ones and two's complement.
Ones and two's complement, not 0. R is 2. So there will be 2's complement and 1's complement. Whereas in decimal system, it will have 10's complement and 9's complement. So you must be aware how to perform subtraction either in binary or decimal system by using either 2's and 1's complement or 10's and 9's complement. Now, in other than the normal binary and decimal codes, there are certain codes which are used in some computer applications. One such example of name is gray code. Another name of gray code is reflected binary code. Now, why this code uses? Now you see, say you have a 2-bit binary number. With the help of 2-bit binary number, how many numbers you can represent? With the help of 2-bit binary number, how many numbers you can represent?
4.
4 numbers. Say 0.
Yes.
0 will be represented as 0, 0. Okay? 1
Yes.
will be represented as
0, 1.
0, 1. 2 will be represented as 1, 0.
0.
3 will be represented as 1, 1. Now you see that যদি আমরা চারটে ছোট নিলাম বলে দেখো তাও যখন 0 থেকে তুমি 1 রিপ্রেজেন্টেশনে দেখছো একটা bit change করছে। 00 is changed as 02, 01. So 10 is changed to 1. But whenever we move from 2 to 3, it changes. 2 is 10, sorry, 1 is 01, whereas 2 is 10. So from moving from 1 to 2, you will have to change both the bits to change the number. আবার 2 থেকে তুমি যখন 3 তে যাচ্ছ তখন আবার 10 থেকে একটা বিট চেঞ্জ করলে 1 1. So in a counter system, as we go on increasing the number, a special type of code is used which is known as gray code. Gray code এর অ্যাডভান্টেজ হচ্ছে তুমি যে কোনো নাম্বারের একটা থেকে আরেকটা এগোতে গেলে only one bit is present, change. As for example, আমি 4 bit নাম্বার নিচ্ছি। 4 bit নাম্বারে 0 তে দেখো 0 is represented as 4 zeros, whereas 1 is represented as 0001, but 2 is represented as 0011, not 10. বাইনারিতে 2 কিভাবে রিপ্রেজেন্ট হতো 0010, but in gray code it is represented as 0011, so that only one bit is changed to number, and 3 is again used, represented as 0010, so that from here to here, if you go on, you only change one bit. Similarly, in case of 4, it is represented like this. So the gray code is used generally in counter system, where we go on incrementing the number by only changing one bit. Clear holo? Gray code টা বুঝতে পারলে এবং gray code এর অ্যাডভান্টেজটা কি? Next
Yes,
one
ma'am.
is BCD code. BCD code stands for binary coded decimal number. Now, whenever we represent number in the decimal system, we can represent large number. As for example, you are representing 631, 6,431. Now, if we want to represent that number 6,431 in binary system, you require a large number of bits. Okay, so to avoid this, another code comes which is known as BCD code. So BCD code basically uses decimal code, decimal numbers, but those decimal numbers are represented in the binary format. Now, that disadvantage of BCD code is obtaining its 9 complements. So whenever we will discuss it in detail. Just you know the number. Sorry. Another type of code is used, which is known as access code. Access code, you can use access 3 code, access 5 code. It is nothing but it is a binary code, but only it is a BCD code. Only the difference is for each decimal digit, its value is added to this value and then represented in the binary format. As for example, you have 3 in the decimal number. Now in the access 3 code, how you will represent it? 3 will be added to 3, so it will be 6. So it will be represented like this. So only by adding these 3, that means 0011, 3 is represented in the binary format like this, 0011. So that will be added to each BCD number and then represented in the access 3 code. Now you can have a question that why this access 3 code is access 3 or access 5 access code is used. We will discuss it later on and you will find its application also. Just you now have the idea that there is one code used which is known as access 3 or access 5 or access 9, any type of access code, which is an extension of BCD code. In the BCD code, each digit is added with this access value and then represented in the binary coded format. Okay, so these are the different types of codes used. Now, whenever we add two numbers, n-digit numbers, the result may be a n+1 bit or n bit. তাই তো? ধরো তুমি 99 এর সঙ্গে 11 যোগ করছো, তাহলে result will be, what will be the result? 110. So it will be a 3-bit number. Now, whenever we do this addition or sub addition in paper and pencil, there is no crisis of space. But whenever we are doing this addition in a circuit, now circuits, each number is stored in a registers. Registers are nothing but a collection of flip-flops. If you have n bit register, it has n number of flip-flops which can have any bit, either 0 or 1. So when we have a n bit circuit, it will be able to store only n bit number. Now if we add two n digit numbers, two numbers of n digit, it may happen that the result is n plus 1 bit. In that case, where the result will be stored, your storing location each has size n bit. So 1 bit will be lost and the result will be erroneous. So in that case, we say there is an overflow occurred. If the addition is performed with paper and pen, there is no problem. But in case of digital computer, because of the size of all registers are fixed, there is a problem of overflow. So we will have to take care of this problem also of the overflow. Clear holo overflow problem ta ki?
Yes, ma'am.
Yes, ma'am.
So this is Jagama chapter madhye shesh hoye geche. This is all about introduction. Next, from next class, we will actually go into the detail. But no, it is not at all introduction. You must be familiar with different number systems, different coding system, conversion from one system to another system. You must be able to perform addition, subtraction using 9's complement, 10's complement, 1's complement, 2's complement. All you should be fluent. Okay. So thank you. From next class, we will discuss. Next class will be on Monday, 3 p.m. Okay, I will send the link. All of you got the link?
Yes, ma'am.
I have also informed in your group mail the link ID. So no problem. কোনো প্রবলেম হয়েছে আজকে ক্লাসে? তোমাদের সঙ্গে আজকে আমার প্রথম ক্লাস হলো, আমি তোমাদের কোনোদিন দেখিনি, তোমরাও আমাকে দেখেছো কিনা জানি না কতদিন এইভাবে চলবে। যত তাড়াতাড়ি আমাদের ফিজিক্যাল ক্লাস শুরু হয় তত ভালো। আজকের পড়াটা বুঝতে তোমাদের কোথাও কোনো অসুবিধা হয়েছে কিনা? তোমরা বইটা জোগাড় করবে না? তোমরা যদি চাও আমি তোমাদের নোটটাও দিয়ে দিতে পারি। নেক্সট ক্লাসের লিংক যখন পাঠাবো আমি তোমাদেরকে এই নোটটা, এই লেকচারটার নোটসটাও দিয়ে দিতে পারি। ওকে,
Yes, ma'am.
ঠিক আছে। তোমরা নোটটা চাও না নিজেরা বই পড়ে? এই বইটা অবশ্য পাবে না, এটা তো একটা ইন্ট্রোডাকশন ওভারঅল। ফ্রম নেক্সট ক্লাস ইউ উইল গেট এভরিথিং ফ্রম দ্য বুক।
ম্যাম, বই থাকলেও আপনি নোটসটা পাঠিয়ে দিলে সুবিধা হয়।
আচ্ছা, নেক্সট ক্লাসে আমি যখন লিংক করবো আজকের লেকচারটা পাঠিয়ে দিয়ে তার সঙ্গে নেক্সট লিংকটা দিয়ে দেবো। ওকে, গ্রুপ মেলে। তোমাদের কোনো অসুবিধা হলে তোমরা আমি নেক্সট মোবাইলে, আমি নেক্সট ইমেলে আমি আমার মোবাইল নাম্বারটা দিয়ে দেবো। তোমরা দরকার যদি মনে করো কোনো সময় পড়া কিছু বুঝতে পারছো না বা কিছু, ফোন করতে পারো। আমি যদি নাও ধরি, অনেক সময় তোমাদের নাম্বারটা আমার কাছে থাকবে না, তো আবার 2-3 বার করো, নিশ্চয়ই আমি একবার না একবার ধরবো। কোনো একটা কাজে ব্যস্ত ছিলাম, হয়তো দেখতে পাইনি বা কিছু। তারপরে নাম্বারটা, নাম থাকলে যেমন তাও বোঝা যায়, নামটা তুমি বুঝতে পারবো না, সেই জন্য হয়তো না করলে তোমরা আর একবার চেষ্টা করো, নিশ্চয়ই পারো। কোনো রকম অসুবিধা হলে সবসময় তোমাদের হেল্প করার জন্য আমি আছি। ওকে, তাহলে কি কথা হলো? নেক্সট ক্লাস হচ্ছে সোমবার 3টের সময়, আর মঙ্গলবার কটায় ক্লাস করবে আমায় বলে দেবে।
ঠিক আছে ম্যাম, আপনাকে মেলে জানিয়ে দেবো।
আচ্ছা, সোমবার কি তোমরা সন্ধ্যেবেলায় ক্লাস করবে 6টার সময়? অসুবিধা হবে 3টে না করে 6টায়?
সবাইকে জিজ্ঞেস করতে হবে।
হ্যাঁ, তোমরা জিজ্ঞাসা করে আমায় জানিয়ে দিও। যদি 6টায় না করো তাহলে 3টে আমাকে কালকের মধ্যে জানিয়ে দিও, তাহলে আমি তাহলে লিঙ্কটা সেই মতো পাঠাবো। আমি সানডে লিঙ্কটা পাঠাবো, তার মধ্যেই জানিয়ে দিও। ওকে,
ঠিক আছে।
Okay, ma'am.
ঠিক আছে। আমি ভেরি সরি, জানি না নেক্সট ক্লাসেও কি হবে। প্লিজ বিয়ার উইথ মি।
থ্যাংক ইউ।
ঠিক আছে, থ্যাংক ইউ।
Thank you, ma'am.
থ্যাংক ইউ।